Okay, so picture this. An AI that doesn't just chat with you, but actually acts for you. I'm talking booking flights, clearing out your inbox, maybe even coding up a website. These AI agents are right around the corner, but they come with this huge flashing warning sign: security. So how in the world do we build them so they don't go rogue? Well, let's dive into the blueprint.
I mean, that's the billion-dollar question, right? When you hand an AI the keys to your entire digital kingdom, you're also painting a massive target on its back for attackers. So the real trick is figuring out how to stop our helpful new assistant from turning into a complete and utter security nightmare.
All right, first things first, let's get on the same page about what we're actually talking about. An agentic AI is not just another chatbot. It's a system that can pretty much work on its own. It can use tools, like your email, your calendar, even the command line to get stuff done out there in the real digital world. And that autonomy, that's what makes it so incredibly powerful and also so incredibly risky.
To even begin to wrap our heads around this, security experts have a framework they call MAESTRO. Honestly, the best way to think about it is like a 7-layer blueprint for security. It maps out every single potential point of failure from the AI's core programming all the way out to the wider ecosystem it lives in.
And here they are, those 7 layers. You've got the foundation model itself, the data it feeds on, the framework it's built on, the infrastructure where it lives, how we keep an eye on it, all the security and compliance rules, and finally, the whole ecosystem of other agents. A single vulnerability in any one of these layers could be enough to bring the whole house of cards down.
So let's start our investigation from the inside out, shall we? We're going to look at the agent's brain. That's the foundation model itself. And then we'll check out its memory, which is all the data and credentials it has to store to actually do its job.
The first huge threat is something called prompt injection. This is a really clever, kind of sneaky attack where somebody embeds hidden instructions inside a totally normal-looking message, all to trick the AI into doing something it absolutely should not be doing.
So, for instance, an attacker might hide a command like delete all files inside what looks like a harmless email. The defense against this is a two-pronged attack. First, the system has to sanitize all its inputs, basically stripping out anything that looks like a suspicious command. But it also does something called session compaction. Think of it like giving the AI a bit of amnesia on purpose, clearing its short-term memory so an attacker can't slowly build up influence over a long conversation.
All right, next up is the agent's memory. To be useful, these agents need to hold on to some really sensitive information. We're talking your login credentials, API keys, you name it. But if that data isn't locked down tight, it becomes a literal treasure trove for any attacker who gets in.
The absolute #1 worst-case scenario here is storing credentials in plain text. It's just a terrible idea. If an attacker gets on that server, they can just read them like a book. So secure systems just don't do this, ever. Instead, they use the operating system's own encrypted keychain to store all the secrets. And on top of that, they run constant security audits to hunt for any credential files that might have been accidentally left out in the open.
Okay, so we've poked around inside the agent's mind. Now let's look at how it actually interacts with the outside world, through its tools. You can think of these as its hands. And just like hands, they can be hijacked.
This one is a really big deal. It's known as tool misuse. And it's one of the most severe threats out there. It's where an attacker tricks the agent into using its perfectly legitimate tools, like a command line or a web browser, for some really nasty, malicious purposes.
And you don't have to take my word for how serious this is. The research puts it perfectly. This is, quote, the most direct path from conversation to system compromise. Yeah, a simple chat message could, in theory, lead to a full-blown server takeover. It's terrifying.
For example, a classic attack is trying to trick the agent into running that infamous rm-rf-4 command, which would just wipe the entire server's hard drive. To stop that kind of disaster, a secure agent has layers of defense. It runs commands in a restricted, sandboxed environment. It requires an actual human to say, yes, this is okay for dangerous operations, and it logs every single thing it does for later review.
So we've seen the scary attacks. Now let's flip the script and focus on the good stuff, the proactive defenses that get built into a secure agent right from the very beginning. The very first line of defense is just simple common sense. Control who gets to talk to the agent in the first place. A secure system uses these temporary, super hard-to-guess pairing codes to authorize anyone new. It's basically a very, very strong lock on the front door. And when I say strong, I mean, wow, just look at that number. That's 500 billion.
That's how many possible combinations there are for a simple 8-character pairing code. And as if that's not enough, they expire after an hour. So trying to brute force guess one, it's practically impossible.
But good security isn't something you just set up once and forget about. It's a constant process. That's why secure agent frameworks have these built-in automated guards like a special security audit command. This little tool is always on patrol, constantly scanning the system for common vulnerabilities. You know, things like exposed networks, insecure file permissions, or those dreaded plain text credentials. And it flags them before an attacker ever gets a chance to find them.
Okay, we've seen the locks, we've seen the audits, and we've seen the sandboxes. Now let's see why every single one of those individual defenses is so absolutely critical. We're going to walk through what's called a chained attack, which shows how one tiny vulnerability can cascade into a total system compromise. This is the ultimate domino effect.
And here's how that nightmare unfolds. Just follow the steps. First, an attacker finds one exposed gateway. From there, they get into the agent's memory and start poisoning past conversations. This manipulation then tricks the AI into creating a brand new, rogue subagent. And finally, that rogue agent can be used to attack other agents across the entire ecosystem. You see how the failure of each layer just opens the door for the next attack?
And that right there is the key takeaway. You have to have a defense-in-depth strategy. It's not enough to just protect the AI model or just secure the network. You have to secure every single one of those 7 layers, because the system is only ever as strong as its weakest link.
This all brings us to the final and most important question. The tools and the techniques we've talked about today are the best practices we have right now. But as these AI agents get smarter, more capable, and more woven into our daily lives, the attacks are going to get way more sophisticated too. This isn't a problem we solve just once. It's a constant, ongoing race. And it's a race that has only just begun.